Hi, Chem students, into our fifth and final video in our bonding unit. Woohoo! It's okay to celebrate. I know you're excited. This video is over intermolecular forces, and I'm starting at the top of page 6 in your notes. As usual, have something to write with and a highlighter. Okay, so intermolecular forces in liquids. If we're lazy, we might call them IMFs, so get used to that as well. Intermolecular forces are forces of attraction between molecules. So bonds are forces of attraction within molecules, bonding different atoms together. Intermolecular forces are forces of attraction between different molecules. So right here is hydrochloric acid. Here's another hydrochloric acid to the right of it. The intermolecular force is the force of attraction between the two different molecules right here. It says they are weak compared to covalent bonds. Think of your intermolecular forces as the glue that holds different molecules together. Okay, so one intermolecular force is called hydrogen bonding. It's a special type of intermolecular force that occurs between molecules that have a hydrogen bonded to either oxygen, nitrogen, or fluorine. These are the three most electronegative elements on the periodic table. Hydrogen bonds are the strongest type of intermolecular force. Okay, a little review. Remember electronegativity. It's a measure of an atom's ability to attract bonding electrons to itself. Electronegativity increases left to right and decreases top to bottom on the periodic table. So nitrogen, oxygen, and fluorine right here are therefore our most electronegative elements on the periodic table. Okay, so for example, a good place where we can see hydrogen bonding is between two different water molecules. So this is the hydrogen bond right here between the oxygen of one water molecule and the hydrogen of a different water molecule, right here being that hydrogen bond or intermolecular force. Remember, it's not a real bond, it's an intermolecular force. It says oxygen is much more electronegative than hydrogen, so it pulls the bonding electrons more towards itself. So oxygen is hogging the bonding electrons. This results in the formation of two dipoles in the water molecule, one for each OH bond. So if oxygen is hogging these electrons, it's pulling them more close to itself, giving oxygen a partial negative charge. Because it's pulling the negative charges, the electrons, closer to itself. A dipole is a bond in which electrons are shared unequally, therefore causing areas of partial positive and partial negative charge to develop. Oppositely charged ends of the dipoles on neighboring water molecules attract, forming hydrogen bonds. Okay, that's a lot, but understand that this oxygen is partially negative. The hydrogens are partially positive, so there's this tiny bit of attraction between them. If we were to line up two hydrogens with each other, they're both partially positive, they would repel. So think of them as magnets. Two positives repel, but a positive and a negative attract. The hydrogen bonding in water explains its high surface tension. Surface tension is an attractive force that pulls down on the particles at the surface of a liquid. In water, the attractive force responsible is hydrogen bonding. What are two pieces of evidence that suggest water has high surface tension? Two pieces of evidence that suggest high surface tension are that water forms these little beads or droplets. It doesn't lay flat, it kind of forms a bubble, if you will, or sits like this on a surface. Another piece of evidence is this little water strider bug guy right here, that he can walk on water because water has high surface tension. These two videos here will be placed on the website so you can watch them and see those two things in action. The hydrogen bonding in water also explains its relatively high boiling point, considering that it's such a small molecule. Remember, the hydrogen bonds are like glue that hold water molecules together as a liquid, so you have to heat it a lot before it changes to gas. So when you add heat, it actually breaks those hydrogen bonds apart so that it evaporates and turns into a gas. It says molar mass or size definitely affects boiling point, but so do intermolecular forces. So it wants us to compare boiling points of these two molecules, which are very similar in size. So this first one we have right here is methane, CH4, and here is water. In CH4, hydrogen bonding is not present. It's hydrogen bonded to carbons, not nitrogen, oxygen, or fluorine. But in water, yes, hydrogen bonding is present. Well, let's see what difference that makes. Their molar masses are similar, 16 versus 18, very close, but the boiling points are a huge difference. For methane, the boiling point is negative 164 degrees Celsius, way below the freezing point of water. So what this means is methane at room temperature is actually a gas. Water, its boiling point is 100 degrees Celsius. You have to heat it up pretty warm to make it turn into a gas. At room temperature, it's actually a liquid. So it says, see what a big difference the presence of a hydrogen bond makes? So again, we are emphasizing here that the hydrogen bonding in the water molecule is holding together these different water molecules into its liquid state. When it's heated enough, those hydrogen bonds are broken, and so it evaporates into a gas. Strong versus weak intermolecular forces. So if a liquid has a weak intermolecular force, it will have a low boiling point, it will evaporate easily and quickly, and it will have low surface tension. On the other hand, if it has strong intermolecular forces, it will have high boiling points, evaporate slowly, and it will have high surface tension. So I want you to think about these two questions. Which molecule do you think has weaker intermolecular forces, vinegar or nail polish remover, and why? So I want you to take a second, pause the video, think about this, and when you come back, I'll have answers for you. Okay, welcome back. So the molecule that has weaker intermolecular forces would be nail polish remover. And the reason is that it evaporates very quickly. So, okay, here's a second question. How about milk versus gasoline? Well, gasoline is definitely going to evaporate more quickly. So I would say gasoline has the weaker intermolecular force. Okay, that concludes our bonding unit. I hope you found the videos for this unit to be helpful. Please feel free to come to tutorials or ask your teacher in class for any help that you may need. Enjoy the rest of your day. Bye-bye.